A dark shape sidles over thick hide, toes braced, bill working like a probe. It opens an old scab, then pauses to pluck a pale parasite before dipping for more. Alarms spill from its throat as if danger lives at the horizon. The host tolerates the attention, even angles an ear toward the instrument. Then a flinch, too deep. Blood wells, ticks vanish, but so does tissue. On this plane, symbiosis is not a promise. It is a ledger. Helpers or thieves, the dilemma hangs between wing beat and wince, a balance measured in seconds and drops. The stage is the African savanna, where large herbivores haul ecosystems across grass and thorn. Parasites ride with them, ticks in hundreds, sometimes thousands, clustering in ears, eyelids, and groin. The bird in question follows the herds, perches low on backs and necks, and lives where the safest ground is moving skin. It nests in cavities, lines the cup with hair plucked from the same mammals it visits, and forages in small parties that reshuffle across daylight. Diets list ticks and other arthropods, but also blood, earwax, and dander. Some hosts invite, others shudder and toss. The anchor frames the puzzle with precision. Helpers or thieves? The Oxpecker dilemma points to a partnership that looks cooperative from a distance and transactional up close. Only after long watching do names settle into place. The red-billed Oxpecker, Buphagus erythrorhynchus, a specialist drawn to the biggest targets on the open range. Here is the paradox, stated exactly as the core mystery. Why do some ungulates accept net tissue loss for vigilance benefits, while others reject the relationship entirely? Reports describe buffalo and rhinoceroses carrying several riders at once, barely responding as bills part hair and search sensitive skin. Giraffes tolerate probing in armpits and groin, areas hard to scratch alone. Yet elephants sweep visitors away, and some antelope shake, twitch, and bolt after a few jabs. Tick loads vary by season and by species, but can be heavy enough to sap condition and transmit disease. When the birds remove engorged ticks, the payoff can be immediate. Less irritation, lower pathogen risk, and relief in places no horn or hoof can reach. But the same bill often reopens wounds to sip blood, extending healing time and creating new entry points for microbes. Their calls complicate the math. Flocks give sharp, chattering alarms at unusual movement. Field observations suggest hosts lift heads sooner and cluster tighter when calls rise. In brush where sight lines fail, that early warning might be worth a scar. The currency is messy, the rates unstable, and the accounts are kept in a body that has other problems to solve. Several hypotheses attempt to reconcile this balance sheet. One treats the interaction as a conditional market. When parasite pressure surges, removal services dominate the transaction. Tolerance rises. When ticks are scarce, blood-feeding behavior becomes more visible and rejection increases. Studies indicate the birds often target engorged adult females, the heaviest bundles of blood and disease, and may ignore smaller stages. That selectivity improves host benefit when tick density is high, yet flips the sign when density drops. Trade-off: a market is only as smart as its current prices. Sudden shifts in tick populations can make yesterday's tolerance costly today. A second idea centers on vigilance as a context-dependent subsidy. These riders live above the eyes and taste fear first. They lift at the smallest cues and call conspicuously. In open habitat, where ambush is rare, the warning may add little. In broken thorn or near human disturbance, an extra half-second matters. Evidence suggests some large mammals change posture faster when the birds alarm, particularly individuals with limited sight or solitary habits. The cost is baked into skin. Thin-skinned or infection-prone species may lose more to probing than they gain from early notice. Thick hides absorb more insult and tip the outcome toward helper. A third hypothesis tracks the geometry of wounds and the mechanics of healing. Bills concentrate at ears, eyelids, and scars, places where blood and parasites co-occur. Reopening keeps access to both. From the bird's perspective, this is efficient foraging. From the host's, it is maintenance with collateral damage. Evolution might favor individuals that permit attention at high-value sites, ears alive with ticks, while rejecting visits to low-value wounds. That discrimination looks like random fidgeting from afar, but careful scoring of flinches, shakes, and resets maps it onto predictable zones. Trade-off. Learning is noisy. Juveniles and stressed adults misjudge often, and outcomes blur over a season. Threaded through every hypothesis is variation that refuses to vanish. Populations differ, and scientists still debate which conditions flip the sign from mutualism to parasitism. The same species that welcomed riders at one waterhole may drive them off after rains change tick composition. The mid-story verdict echoes the title with its full weight. Helpers or thieves? The Oxpecker dilemma remains a moving target, rewriting what we thought we knew about tidy categories in animal behavior. What endures is a process rather than a label. A rider scans while it feeds. A host suffers a cut for a warning it cannot purchase elsewhere. Sometimes the cost is small and the benefit large. Sometimes the math reverses and the visitor becomes a thief with good manners. The ledger lacks a final column. If the future brings denser thorn, shifting predators, or new pathogens, tolerance may climb on some backs and collapse on others. In the long run, evolution will price the exchange. Until then, a wing beat lifts, a call snaps through grass, and a wound closes just enough to invite the next decision.